So here's exercise 7G. I know you're all going to bombard me with questions all at once, so I'm getting prepared. So number A, find the equation of the tangent to the line to this curve. What does it all mean, I hear you ask? Well, let's take a look at this curve. What does it look like? Lo and behold, it's a sweet parabola, and they're asking to find the tangent at the point -3, 4. So here we're going to try and find the equation of the tangent, which is sort of like that. That was pretty crap drawing, but as close to that as I can get, like that. We've got to find the equation to that line. That's all it's asking us. So first of all, we've got to find the gradient function. So we're going to differentiate this. So let's write the equation first. Is equal to x squared plus 2x plus 1. Now to find the gradient function, I'm going to differentiate that. So remember, take the power to the front, so 2, and then x, and then make this power minus 1, so that becomes 1, plus take the power to the front, 2 times 1 is 2, and take this power minus 1 is x to the power of 0, x to the power of 0 is equal to 1, so that's the gradient function. Which means anywhere on this line, if I substitute in the x that's needed, I will find the gradient of the tangent at that point. Now, I've been asked to find it at this particular point where x is equal to -3. So substitute in x is equal to -3 here, and that will give me the gradient of the tangent. So -3 plus 2, that's equal to -6 plus 2, that's equal to -4. Well, now I can find the equation of that line, of that tangent, because I have a coordinate that's been given it, -3, 4, and I have the gradient. So if you remember that the equation of a straight line, you're used to seeing it as y is equal to mx plus c, but I don't know what c is. I don't know what that is at the moment. I mean, I could find it out, but the best thing to do is to use this version of that line, y minus y1, because you have a coordinate and you have the gradient. Now, and then you can just substitute that in. So you know that that the gradient is -4, and here you can put x minus -3, that's from here, and y minus 4, and that's from here. Now you might, if you've forgotten where this sort of comes from, let me just remind you that you know that the gradient, which is m, is equal to the rise over the run. What is the rise over the run? Well, the rise is just the difference in y values over the difference, and the run is the difference in x values. And that's how we get that equation. So if you say gradient is equal to y minus y1 over x minus x1, and you simply rearrange that equation by multiplying this to this side, then you end up with x minus x1 times the gradient is equal to y minus y1. And I've just switched that around because we like to have our y's on this side. That's just convention, doesn't really make any difference. And then if I substitute that in like I did before, y minus 4 is equal to -4 times x minus -3. Multiply that out, make it look tidy. Minus 12, because we've got -4 times plus 3. And to make it even tidier still, it's going to look like that. And that is the equation of that tangent line that we did before. Now I could actually do a more accurate drawing now that I've got this. So if you're asked to sketch it, all you need to do is substitute in another x to get another y, and then you've got 2 points, and you can make a very accurate drawing. So here's the equation, and here's my graph, and I'm going to make my gradient line more accurate. So I'm just going to find out what x is if y is 0. So let's substitute that in. That means -4x is equal to 8. That means x is equal to -2 when y is 0. So y is 0 here, just go along to -2 is here. So now I've got those 2 points. I can draw a more accurate tangent, and it should look like this. So here's a more accurate drawing of this particular tangent line. And that means you might be asked to do a sketch, so you need to be able to show a decent sketch. You can also use your GDC to check what it looks like as well. Now you probably don't need help with every question, so I'm going to make a big number like that. You can just scroll forward to the question that you want. So now 2b. When I'm doing these problems, I find it super interesting to figure out what would this graph actually look like. So let's start. If x is equal to 0, I put 0 in there, then it must start here at 4. And if x is equal to 1, then that must be 2, so it must be 6. So it's 5, so it must be there. So it's going to sort of go like, that somehow. So I'm asked to find the tangent where x is equal to 1. So I know that when x is equal to 1, y is equal to 6. So somewhere like that. So it's a positive tangent. So let's see how we go about this. If I look at the equation like this, it's not very friendly for differentiating, so I'm going to rewrite that to make it more differentiation friendly. So I'm going to put it like that. So now I can make this f dash, I can differentiate, put that to the front, so 2 times that's 1, and then a minus 1 here, so that a half minus 1 is negative a half, and then this is a constant, so I don't need to that doesn't make any difference to the graph. It just shifts it. It doesn't change the tangent gradient. So I've ended up with the gradient function as square root of x on 1. Whoops, I just made a terrible mistake. Let's get rid of that. So let's just rewrite this straight away. Okay, so that's equal to x to the negative a half. Okay, well, I could also say this is 1 on square root of x, but I'm going to leave it like that for now. So now I want to write the equation, and I know now that it's at x is equal to 1. So the gradient has to be 1. If x is 1, then the gradient is going to be 1, because the square root of 1 is 1, and 1 over 1 is also 1. So what about the point? I need a coordinate. Well, I know it's 1, and I also know if I put 1 into there, the y value would be equal to 6. Okay? I just substituted in my x value into there. Square root of 1 is 1, 2 plus 4 is 6. So now I can use this equation to get the graph, to find out what the tangent is actually going to be. So y minus 6 is equal to 1 times x minus 1. So y minus 6 is equal to x minus 1. Y is equal to x plus 5. And that's the answer, my friends. That's the equation of the tangent line to the curve at that given point. Yay! Question 2c. With this question, you could use the quotient rule, or you could rewrite this to make it a little bit more friendly. Either way, you're going to end up with the same answer. So let's do it both ways. I'll show you what you do if it's the quotient law. Okay, see if you can remember this. You take the denominator, it's x, and multiply it by the derivative of the top line, so that's going to be 2x. Did I lose you there? That's because if the derivative of this is just 2x, right? And then you subtract the top line, the numerator, times the derivative of the denominator, and the derivative of x is just 1, don't really need that there, and all over the denominator squared. Okay, so that would be 2x squared minus x squared minus 6 over x squared, which is equal to x squared minus 6 over x squared. And I could break up that fraction and say x squared over x squared minus 6 over x squared, which is just equal to 1 minus 6 over x squared. And that's how you would get the derivative if you were using the quotient rule. But you could also rewrite it and make it a little bit more friendly and do it a different way. Let me show you. I could just break this fraction up, because this fraction is like saying x squared over x plus 6 over x. And what is x squared over x? Well, that's just equal to x, right? Plus 6 over x. And then I can differentiate that. So let's differentiate x. So differentiating x, that's just going to be 1. Because remember, you take the power to the front and then minus that. And then differentiating this here, well, actually, we should have written that really as 6 times x to the negative 1. That makes life easier. So that's going to be plus, and this to the front, negative 6, and then x to the negative 2. So that's going to equal 1 minus 6x to the negative 2, which is exactly what I had there. 1 minus 6 over x squared. So you can decide for yourself whether it was worth using the quotient rule or whether just to rewrite it and do your differentiation there. Now it asks for the tangent at the point where x is 3 and y is 5. So let's substitute in the 3 to find out what our gradient will be at that particular point. So that's 1 minus 6 over 3 squared, which is equal to 1 minus 6 over 9. And let's simplify that down to 1 over 2 over 3. So 1 minus 2/3 is equal to 1/3. So that's the gradient of the tangent. Now we just need to write the equation. And we've already got this coordinate that it's going to go through. So I'm going to squeeze this in here. So y minus 5 is equal to 1/3 of x minus 3. And let's make that a bit neater. 1/3 x minus 1. So y is equal to x over 3. And I take this 5 and bring it over there and make it plus 5. So minus 1, so it's plus 4. And that's the equation that you need. That's the equation of the tangent to the line. Tangent to the curve, sorry, at that given point. That's your solution. Question 2D. Well, this is a super interesting looking curve. It's going to look something like that somewhere. Anyway, it looks like a mess, but there's no need to get your knickers in a twist because you can just rewrite this into a more friendly way for differentiation. So this is just x to the negative 1/4. Whoops, not negative. What am I talking about? X to the 1/4 plus 8x to the negative 1/2. Okay, now we're talking. Because remember, this is just x to the 1/2, but it's on the bottom, so it's negative. So now let's differentiate that. That's not so difficult, is it? So we take this to the front. So that's 1/4. And then we have to subtract 1 from this. So what's 1/4 minus 1? It's going to be negative 3/4. Plus, now remember, we take this to the front. So that's negative 1/2 times 8 is negative 4. And then negative 1/2 minus 1 is going to be negative 3/2. And that's our gradient function. It looks a bit scary, but they're only asking us for x is equal to 1, so that's being very nice to us. So now if we find out what the gradient function, we find out what the gradient of the tangent is at the point x is equal to 1. So we just put that in. 1 to the power of negative 3 on 4. What do you think that's going to be? Plus negative 4, 1 to the power of negative 3 on 2. What do you think that's going to be? You guessed it. It's just 1 on 4 minus 4. Okay, so let's simplify that down. If you think of this 4 as being 16 on 4, we're going to end up with 1 on 4 minus 16 on 4 is negative 15 on 4. And that's the gradient of the tangent at that point. So, but they're asked to get the equation for the tangent. So we need a coordinate, but we only know what the x is. We know that x is equal to 1, but what's y when x is equal to 1? Well, we need to put that back into the original equation now. So what's that going to be? If we put 1 x is 1 into this original equation, we're just going to end up with 1 plus 8, which is equal to 9. So now our coordinate point is 1, 9. So now we can go back and put this into our equation of the line. So y minus 9 is equal to negative 15 on 4 of x minus 1. Still looks like a bit of a mess. Well, you could leave it like that if you want, or you could bring it down and bring that 9 across. So this would be negative 15 on 4x minus plus 15 on 4 plus 9, just 54. So that's 51 on 4. You could make it look like that. But this is also correct. That's totally fine. I just like to make it neater like that. Have as a y equals. Either way, it's very good. Carry on. Question 3 is really the same, except that they want the equation of the normal line. So it's not really any different to the other one, except that the gradient is going to be the negative inverse. So if you have a gradient of m, if you have a gradient of m, and there's a line perpendicular to that, that gradient will be the negative inverse of the gradient of the line that it's perpendicular to. This is very straightforward because they've even given us the entire coordinate point, so it's going to be super easy. So let's differentiate that. Now you know that you take this power to the front, 2 times 2 is 4, and then minus one of those powers, that's just x. Now this one, imagine this is 1 here, so we're going to multiply that by 1, and the x becomes to the power of 0, which is 1. So that is the gradient function. Now we want it at the point where x is equal to 2. So the gradient is just going to be 8 minus 1 is just going to be 7. See if I put 2 into there. And but that is the gradient of the tangent, my friend. But we want the tangent, we want the gradient of the normal so that we can create the equation. So the normal is going to be the negative inverse of that, which is simply negative, because this is positive, negative 1 over 7 is the gradient we want for the normal. So we've got a point here. We've got the coordinates for this point here, so we can just go ahead and say y minus 3 is equal to, here's the gradient, x minus 2, and then just tidy that up really. And we can keep tidying that up if you really want to. But I like things to be tidy, so I'm just going to think of that negative 3 as 3 times 7, 21 on 7. So I'm going to say y is equal to negative x on 7 plus 21 on 7 becomes plus 23 on 7. So either of this is fine, but this is even better. It looks nice. Ta-da! Question 3b. Again, for this question, we really want to write this in a way that's more friendly for differentiation. So I'm just going to switch this around a bit like this. Now it's much easier for me to differentiate that, because now I just take this negative 1 to the front. So that becomes negative 4, and negative 1 minus 1 here is negative 2. And then here I take this negative 2 to the front, so that's negative 2x, and then this 1 minus 1 becomes negative 3. So let's make that neater, plus 2x to the negative 3. That's my gradient function right here, and I need to find out what it is at this point. So I need to put in x is equal to negative 1 to find the actual gradient here. So I've put in negative 1 here and negative 1 here. But you might prefer to look at this in a different way to help you with that, because this is exactly what it is. Right? Now think about putting your negative 1 into here. If I put negative 1 into here, it's going to be positive because I'm squaring it. So this remains negative 4. And if I put negative 1 into here, it's going to be negative. So it's going to be, because I'm going to have Negative 1 times negative 1 times negative 1 is going to be negative 1. So then this is negative 6 is the gradient here. The gradient here is negative 6. But that, ladies and gents, is the gradient of the tangent. And I want the normal. So the normal must be the negative inverse. I've got negative 6, so it's going to be positive 6, but 1 over 6. That's the gradient of the normal. Now, looky here, I've only got the x value. How am I going to get the y value? Well, I have to go back to my original equation and ask myself, what is y when x is negative 1? Well, if this would be, if I put negative 1 in here, that's negative 4. And I put negative 1 in here, that's just a bit of 1, that's just going to be negative 1. So it's going to be negative 5. Okay, so now I've got enough information to create the equation. So it's going to look a bit like this. If I can come down the bottom here, we'll do this in green. Y minus negative 5 is equal to 1 over 6 x minus negative 1. Okay, so tidying that up, just move this up a bit. That's y plus 5 is equal to 1 on 6 x plus 1, and obviously I don't like it looking like that, so I'm going to say y plus 5 is equal to x over 6 plus 1 over 6, and imagine that this is equal to 30 over 5, so I'm going to say y is equal to x over 6 minus 29 over 6, because I made this 30 over 6 and subtracted it on that side. But either of these are fine. This one here or this one here is my favorite. But this is also okay, I guess. Well, it's right. Question 3C. This is an exciting question because I could use the chain rule here, couldn't I? I could just say y is equal to u squared and u is equal to 2x plus 1. And then I could say dy of du is equal to 2u and du of dx is equal to 2. And then I can just multiply those two together. So that's 4u and substitute back into the u, and that's 4 outside of 2x plus 1. Which is equal to 8x plus 4. I could do it that way. That's fantastic. Or I could just multiply this little sweet thing out, and then I've got f of x is equal to 4x squared plus 4x plus 1. And lo and behold, if I differentiate that way, look, 2 times that, that's 8x plus 4. Yay! See how exciting that is? I could have done that with the chain rule here and here and multiplied to get that. Or I could have just expanded it out and got that. And pretty much both of them were super fast. So whichever way you do it is fine. Anyway, back to the question. We have to find the gradient function at 2. X is equal to 2. So let me move this up a bit. So putting 2 into there, that's equals 16 plus 4 is equal to 20. But this is the gradient of the tangent function, right? Of the tangent. And I need the gradient of the normal. So the normal gradient, very funny, gradient is going to be the negative inverse, okay? So that's the negative inverse. And the point we were given was 225, right? So now I can just go y minus 25 is equal to negative 1 on 20. Gosh, what a mess. X minus 2. And that's okay, but you know me. I want to make it look pretty. So I'll say y minus 25 is equal to negative x on 20 minus 1 on 10. Yeah? Oops, plus. What am I talking about? And then I'll just say y is equal to negative x on 20 plus 25 and 1/10. Does that look better than that one? Yes. Anyway, this is cool, but this is also sweet. That's the equation of the normal. What's normal around here? Question 3 D. Well, you can probably guess that I'm going to tell you that we're going to make this friendlier by rearranging it so it looks like this and bring this to the top, because that's going to be easier to differentiate. So let's differentiate that. Remember, we take this to that side. That's 2 over 3 x, and then a third minus 1 is going to be negative 2/3 minus, and then take this to the front. So that's going to be negative 8x. Negative 2 minus 1 is negative 3. Let's make that look a bit neater so that we can substitute in easier. So it's 2 over 3x to the 2/3 minus, plus 8 over x cubed. Okay. So the question is very friendly because they've asked x is equal to 1. So that makes that life a little easier. If we put 1 into there, it's not going to be too awkward. So that's just going to be 2/3 plus 8. And we can put that together. If we think of 8 as being equal to 24 on 3, we end up with 26 on 3. Okay? Either way. But that is the gradient of what? Okay, remember this is the gradient of the tangent, and this question wants the gradient of the normal. So if that's the gradient of the tangent, the gradient of the normal is going to be the negative inverse of that. So we're going to negative 3 on 26. Yuck. Now, we know that x is equal to 1, but we don't know what y is. So we have to go back and put 1 into the original equation to find out what y is. So put 1 in there and 1 in there. So it's just going to be 2 minus 4. So that's negative 2. So that's what we need there to put into our equation to get the equation of the normal. So now y minus negative 2 is equal to the gradient over x minus 1. So y plus 2 is equal to negative 3x on 26 plus 3 on 26. Whew, bit of a mess. Y is equal to negative 3x on 26. I'm going to take that as 52 on 3. Actually, it's a bit of a mess. I could change it around like that, but you may as well just leave it like this. That's fine. But this is also sweet. I love this question. This is number 4 because it's just so funny. It says, find the equations for all the vertical normal lines to the graph. Well, a vertical line is like that, right? That's a vertical line. That's the vertical line. That's the vertical line. Now, if it's a normal, it must be perpendicular to the tangent, right? Perpendicular to the tangent. So that means the tangents must be horizontal. Haha, that's super funny. So what's the gradient of a horizontal line? Doesn't have any slope. So the gradient's got to be 0, right? Has no slope. So that's a really, really clever question. Did you get that? Well, let's have a look at what the graph looks like, and then that might make it even easier to see what they mean. So this is what the graph looks like, which is super cool. So it says vertical normal lines, vertical meaning like that, to the graph. So that if they're vertical, then the tangent, so there's one tangent that's got to go there and one that goes there, that's going to be horizontal, and then that'll have vertical normals like that. So that's sort of roughly what we're looking for here. So how are we going to do that? Well, first of all, like I said, the tangent gradient has got to be 0. So let's differentiate this first. Dash equals 3x squared minus 3. So this must be equal to 0 at the points that we need it. So let's see what that is. So 3x squared minus 3 is equal to 0. That's the points we want. Therefore, that's a parabola. How cool is that? The gradient function is actually a parabola. I love it. So let's take this. See, look, if you take 3 outside, you'll see that this is difference of squares. Yeah? What is the difference of squares? Well, it's x plus 1 times x minus 1. Well, if that's going to be 0, in this case, x must be equal to -1 and x must be equal to +1. Well, that makes sense, and that's the actual equation, right? Because look, here it is. X is equal to 1, that's the graph, and x is equal to -1, that's the graph. That's the equations. That's what the equation is. That's what it is. How exciting. It's just a vertical line. Actually, it's 2 vertical lines. Question 5, but I bet no one's listening to me by now because you probably should all be experts, yeah? So this is telling me that at x is equal to -1, the gradient is 1. So if I take the gradient function, so f dash x, if I take the gradient function and put -1 into it, I should get 1, right? And that'll help me find k. So differentiating this, I put the 2 into the front and then -1 there. I have 4x. Now here, remember that x is to 1, so 1 times k, so plus k, and the x goes away because that's 1 minus 1 is 0. So that is the gradient function, okay? Now it's telling me that the gradient of the tangent at the line of x is equal to -1 is 1. So that means if I put in x is equal to -1 here, so 4 -1 plus k has to equal 1. Okay, so -4 plus k is equal to 1, therefore k must be equal to 5. And that's it. How simple was that? Wow. Did you get it?